I probably should have resized this to make sure it fit, but this is still 2.1. This is a conclusion of this. Now I believe we already found all of these derivatives. So you could double check my work, but I believe we already did these before. That we got negative 2x minus 4. And the point that they want to get out of this is if you find the value of the derivative at this point, so now it's asking you to do f prime of negative 1. So negative 2 times negative 1 is positive 2 minus 4. You get negative 2. What they're trying to get at here is that you could also do this problem for a specific point, like x approaches negative 1. So this function, so f of x is the same as before, negative x squared minus 4x plus 1. And then minus f of negative 1. Well, what is f of negative 1? Well, square it, you get 1. Negative 1 plus 4 is 3 plus 1 is 4. All over x minus negative 1, so it turns out to x plus 1. Well, if you then, here, let me just put these together. So 1 minus 4 is negative 3. And it might actually be to your benefit to factor out a negative there. So by factoring out a negative, what will happen is this becomes plus x squared plus 4x plus 3. I hope you understand everything I'm doing. So what we have is the limit as x approaches negative 1 of the negative of, you could factor this as x plus 3, x plus 1. Well, that's kind of nice because you can put x plus 1 now. Cancels with the denominator. I'll switch back to the other color. Now when you plug in negative 1 in right here, well, negative 1 plus 3 is 2, and then you have negative 2. So you get the same answer. So what we're trying to get at is this is an alternative way of finding. The problem with this method, though, for finding the derivative is it doesn't give you an equation. It only lets you do it for specific x values. That's why we usually teach the other one. That's why the other formula, the h approaches 0, even though it looks weird to begin with, it's actually more user-friendly. So again, I believe we already did this one, finding the derivative. Correct me if I'm wrong, but I believe it was 1 over 2 square root of x plus 2. And when we did f prime of 7, it was 7 plus 2 is 9. The square root of 9 was 3 times 2 is 6. We got 1 6. So we could do this process again. The limit as x approaches 7 of the function, I don't know why I just typed that, square root of x plus 7 minus, plugging in 7 in for x, 7 plus 2 is 9, square root of 9 is 3, all over x minus 7. So we would go through a similar process that we did before in chapter 1, where you'd multiply top and bottom by x plus 7 plus 3 over square root of x plus 7 plus 3. So as you FOIL the numerator, the square roots go away. So we're looking at x plus 7. Outside is positive, inside is negative, so they cancel. Negative 3 times 3 is 9. I just realized I made a mistake. I'm sure you guys caught it already. Is f of x is this. I rewrote it wrong. It should have been x plus 2 right there. Because remember, it's f of x, and I got ahead of myself. F of x is that. Now the bottom was correct, but this should have been x plus 2. So this should have been x plus 2 minus 9. And in the denominator, that x minus 7 is good. I realized that something was not going to cancel, so I knew I did something wrong. So if you look in the top, x plus 2 minus 9 is x minus 7, so they'll cancel with this. So you still have a 1 on top, remember that. And now I can directly substitute 7 in here. Well, the square root of 7 plus 2, so 7 plus 2 is 9, square root of 9 is 3, plus 3 is 6, so we're left with 1, 6. So what we have is, I'm just going to type this out, an alternative definition of the derivative. You might see this a few times. That's why I need to bring it to your attention. But as I mentioned, it's not as user-friendly because it only gives you the derivative or the slope at x equals a. So it's not as nice. So it only finds the slope at x equals a, whereas the form that as h approaches 0 gives you the answer for all. So instead of going to the last slide for these notes, I just figured I would share the answer key with you, and you can pause the video and you can write this down. But that definition of the derivative, the top thing, produces a function that you can put in any x value that you want, and you can find the particular tangent line, whereas the bottom one will only give you a value. So you'd have to do the problem over and over again, but you need to know both because any of them can show up at any point when we take the AP practice test or the actual thing. And this concludes section 1.